So hello everyone, welcome to this new video. So in my previous videos, we had started with module 4 about the introduction to ARM processor set, and we have discussed different types of register files and the ARM core data flow model, CPSR, banked registers, processor modes, everything is covered, okay, till now. Those who have not seen those videos, please go and watch it. It is available in the channel. Also, this notes would be available in the description. Go and access it and download it and study it, okay, because this is a standard notes which is provided by the VTU sync.in website. Okay, so this notes is very very essential. All the concepts are covered in a beautiful manner. This notes I'm going to put it in the description. Go and check it out. Okay, so today we are going to continue with the conditional flags. Okay, condition flags. Under the CPSR we have some of the conditional flags which you have seen. Those flags and all we are going to see what are their uses, how it is used. Okay, the condition flags are updated by comparisons and the result of the ALU operations that specify the S in the instruction suffix. Okay, so those are the conditional flags. So if you these conditional flags would be activated only if we use one instruction, and after using that instruction you should be adding the letter S, okay, as the suffix, because that S would be calling towards the CPSR, and it would be going to the CPSR, and at that CPSR end the register we have some conditional flags right in the CPSR part, and under that the conditional flags would be getting updated. Okay, so that S suffix is very very important in these conditional flags. For example, you see here, if a sub instruction is used, that is subtract instruction, and after that they have used one suffix s here, okay, that results in a register value of 0, then the z flag in the CPSR is set. Okay, this particular subtract instruction specifically updates the CPSR. With processor cores that include the DSP extensions, the Q bit indicates an overflow. Okay, if an overflow or saturation has occurred in an enhanced DSP instruction. The flag is sticky in the sense that the hardware only sets this flag. To clear this flag, you need to write the CPSR directly. Okay, if you write the CPSR directly, this flag, that is the Q bit flag, would be cleared. Okay, it is always set to 0. In Jazelled enable processes, that is the J bit, it reflects the state of the core. If it is set, the core is in the Jazelled state, but the J bit is not generally usable. Okay, it is not generally used in the ARM processor and is only available in some processor cores. Okay, to take advantage of this Jazelle, an extra software has to be licensed from both ARM Limited and Sun Microsystems. Most of the ARM instructions can be executed conditionally on the value of the condition flags. The following table lists the condition flags and a short description on what causes them to be set. Okay, so you see here, these are the different condition flags. That is Q, flag name is saturation. Then we have V, that is overflow. C is the carry flag. Z is the zero flag. Okay, and N is the negative flag. Q, that is the saturation flag. The result causes when an overflow or saturation would be happening in the flag. Then V, that is the overflow. The result causes a signed overflow. Okay. C, that is a carry. The result causes an unsigned carry. Okay. Next is 0. The result, when the result is 0, while doing the processing part, if we get the result as 0, then the 0 flag would be updated to 1. Then N, that is the negative flag. If the bit 31 of the result is binary 1, okay, if the 31st bit of the result is binary 1, then the negative flag would be set as 1. Okay, so these are the causes when these flags would be set. It is mentioned here, so please note it down. Okay, these flags are located in the most significant bits in the CPSR. That is the, as I've told you, in the MSB part, these flags are set here. Okay, these bits are used for conditional execution. The following figure shows a typical value for the CPSR with both DSP extensions and Jazelle. Okay, so you see here, DSP extensions means all the conditional flags are there, and one Jazelle bit is there. Along with that, we have the field bits, that is the interrupt, interrupt request, fast interrupt request, and one thumb state, and this is the SVC, that is the supervisor mode which you have used here. Okay, here you see here the conditional flags NZCVQ. It has the specific values, that is 0, 0, 1, 0, and 0. So if you observe this very carefully, when you say that if it is when any of the flag is set, right, it would be represented in the capital letter. Okay, if you want to uh, uh, during the programming part and all, the pre and post execution part, if you want to remember this part, then you should be remembering that whenever any flag is set, the respected letter of that is represented in capital. Okay, since the all the negative, zero, overflow, and saturation flags are zero, so then all those remaining are kept in the small letters. Only the carry flag is capital. Okay, so that indicates that the carry flag is set in the CPSR. Okay, and this is a small letter again. Then we have IF, so F is capital since it is 1. Then this is processor mode. Okay, so in the most MSB part we have the condition flags, and these are the condition flags. Okay, this is represented in a CPSR. For the condition flags, the capital letter shows the flag has been set. Okay, this I've already told you. For interrupts, a capital letter shows that the interrupt is disabled. Okay, for interrupts, if there is capital letter, then it shows that the interrupt is disabled. The rest all the interrupts are enabled. Okay, in the CPSR example shown in the above figure, the C flag is the only condition flag which is set. Rest all the NZVQ flags are clear. Okay, so that is they are not set, they are zero. Only the carry flag is 1. The processor is in ARM state because neither the Jazelle J or the thumb bits are set. Okay, so when we say that the processor is in ARM state, when both the Jazelle bit, that is J bit, or and the thumb instruction bit, if any one of them is not any one of them are not set, then we say that the processor is in ARM state. Okay, the IRQ interrupts are enabled and the FIQ interrupts are disabled. Finally, you can see from the figure the processor is in the supervisor mode, and that is represented as SVC, since the mode is 4 down to 0 and it is equal to binary 10011. Okay, since it is a 5-bit mode, it is equal to 10011, so that's why it is in the supervisor mode. Next, you see the conditional execution. The conditional execution controls whether or not the core will execute that instruction. Prior to execution, the processor compares the condition attribute with the condition flags in the CPSR. If they match, then the instruction is executed. Okay. Otherwise, the instruction is ignored. Okay. So the condition flags, the execution of the conditional in the conditional way under the conditional flags, it compares the condition attribute. Okay, within the conditional flags in the CPSR. Okay, if the conditional attributes match along with the conditional flags, then the instruction is executed. If they are not matched, then the instruction is said to be ignored. Okay, next you see here the condition attribute is post fixed to the instruction mnemonic, which is encoded into the instruction. The following table lists the conditional execution code mnemonics. When a condition mnemonic is not present, the default behavior is to set always the AL execute. Okay, so this is the conditional mnemonics table here. Okay, it represents whether it is equal, not equal, and all. You see here, when it is equal, it is Z. When not equal, it is small z. Like that, it is mentioned here. Okay, so just read it once. This table. This is not so important, but it is for your reference. Okay. So this was all about the conditional flags under CPSR. Hope you understood it, each step. So that's all for the video, guys. So one more video is left that I'm going to cover in the next session, and we are going to wind up this module. Okay. So that's all, guys. Support us. Keep supporting. Like, share, subscribe to our channel. We'll see you in the next video. Thank you.